Okay, good morning. This is Math 0310. It's April the 3rd. Some announcements to get started here. Exam 2, I did post those grades on WebAssign on your WebAssign gradebook yesterday. So be looking for your grade there on your WebAssign gradebook. Remember, go to grades and you can find it in there. And if you're having trouble finding it in your gradebook, let me know and I'll give you instructions again on how you can get meander your way through the links on WebAssign, because you do have to hit 2 or 3 buttons before you get to your grades actually. Sandra just asked me about this, but email me if you want a graded copy of your exam. Do not send me a remind message. Please send me an email and I will respond to that email with a copy of your graded exam attached to it. I do not have a problem doing that at all. So please, if you need a copy of it, let me know. A couple of things that kind of pertain to grades and pertain to your exams. Don't forget that the final exam replaces the lowest exam grade. So if you have, we have 2 tests so far. If one test is decent and the other test is not, remember that the final exam will replace the lowest test grade. Final exam also counts 20% of your final grade at the end of the semester. Also keep that in mind as well. But in addition to that, it could also replace the lowest test grade. So final exam can help your grade out significantly at the end of the semester. We haven't really talked much about it, but there will be a review for the final exam. There is a review on the math department website, and I'll be posting a review through my Google site also, but I'll probably wait until we get closer to exam 3 before I post the review for the final exam, but there will be a review for the final exam also. The W day, the last day to withdraw from the class. Now I have on here April the 6th, but now I was just reading something on an email, and so you guys can correct me if I'm wrong, but something on the email suggested that this was April the 5th, and it was Thursday. So if you have a question about your grade, the person you should talk to is me. Obviously, I'll be happy to talk to you in person, talk to you through Remind, talk to you through email, however you want to do that, and we can talk about the status of your grade. Remember that because of the level of this class, that if your grade is not passing at the end of the semester, but you're participating, you do not get an F in the class, but you get an IP. An IP just means the class is in progress, and that you would have to re-enroll if you're trying to get through intermediate algebra. So you should talk to your counselor about that in more detail, but that, and I can help you with that also. But that's kind of the status. So it does not affect your GPA at all. An IP doesn't. So, but it could have ramifications for your GI Bill if you're a vet. It could have ramifications if you are a financial aid student in another way. So you have to talk to your financial aid counselor about that, because I do not know all the rules and laws and everything. WebAssign. You do have Chapter 10 homework that's due today. I did extend it one more day. So you have homework that's due today, 10-1, 10-2, 10-3, and 10-4. So make sure that you're getting those assignments done. Some of you have gotten a little bit behind on WebAssign. You need to keep up with that. WebAssign should be a grade that will help your average at the end of the semester, because because you can rework problems an infinite number of times, basically. There's no reason why, if you allow yourself enough time, you shouldn't get a 100 on every WebAssign homework. And some of you in particular who are listening to me right now live, I know do that. You're getting hundreds on all of your assignments, and you're doing all of those, and that will just help your average at the end of the semester. Today, we started talking about equations of lines last time. We started talking about graphing in the plane. And so today our emphasis is going to be everything having to do with slope of a line. So we're going to talk about the slope again. We did a little bit with that at the end of lecture last time. We're going to look at slopes of horizontal and vertical lines, the slope-intercept form of a line, finding slopes from equations, and writing equations of lines. So that's if there are no questions. So let me pause just for a second here. For those of you who are with me live, anybody have anything that they need to ask about before I get started with the actual lecture? Anything?
No questions.
Okay, thank you. Thank you, Taylor, for that. Then we are going on to slope of a line. So slope of a line is what we want to talk about. And so first of all, remember that if you're talking about a line, so let me just sketch just any old line. So here's a line right here, and you have 2 points on the line, and we call one of those points x1, y1, and one of them x2, y2. That the slope of this line, first of all, we use the letter m, the small letter m for that. And in words, the slope is the rise over the run. And using the words rise over run, I think is a perfectly good thing to do here to help you think about what the slope of a line is. So the rise, you're starting at one point, right? You're talking about how much you're rising from that point, and then the run is you're talking about how far you're going left or right, and so that would be the run right there on the picture. All right, and then the rise and the run actually can be calculated, right? The rise is y2 minus y1. It's just the difference in the y values. And the run is the difference in the x value. So it's x2 minus x1. And so that's a nice little formula for the slope, y2 minus y1 over x2 minus x1. Okay, so if you have, let's say we have this equation right here. Let's say we have, and this will give us a chance to do a little reviewing also. We have 3x plus 5y equals 9. And I wanted to graph this equation and also talk about its slope at the same time. All right, so what we could do here is we could identify a couple of points. And so remember, one way we did this in lecture last time is we looked at the x and y intercepts for this line. Now, don't forget that the x and y intercepts, if you're going to do this with the t-table, the x and y intercepts are simply what happens when you put 0 in for y and when you put 0 in for x. Remember, when you put 0 in for y, you're talking about the x-intercept. And when you put 0 in for x, you're talking about the y-intercept. So in this equation, when I put in 0 for y, I get 3x plus 5 times 0 equals 9. Or 3x equals 9, or x equals 3. So our x-intercept's at 3, 0. The y-intercept, I put 0 in for x. So you have 3x plus 5y equals 9. Y is equal to 9/5. And so you have a y-intercept at 0, 9/5. Okay, and so those are 2 points on this graph. And so if you wanted to, let's see, so let's go ahead and graph this. And by the way, remember, 9/5 is 1 4/5, just to make sure that you put that in the right place. I get all sorts of crazy places for fractions when people are graphing those. Okay, so you get the point 3, 0, and you also have the point 0, 9/5. So that's 0, 1 4/5, which is about right here. That's a good estimate of where it's located. And so here's our line right here. And, you know, if we were looking at the slope of this line, then one way we could look at the slope of this line is we could use those 2 intercepts, for example, and we could go ahead and look at the rise and the run, right? That the rise, in this case, is like that. It's down, right? And the run, and it's down how far? 9/5, right? You're dropping negative 9/5, and the run is this distance right here, which is 3. And so if you're thinking about the slope as rise over run, you're simply getting negative 9/5 divided by 3, like that. Or that's negative 9/5 times 1 over 3, right? You dividing by 3 is the same thing as multiplying by 1/3. Sandra, did you raise your hand? Did you have a question? Okay, I thought I heard a question there. So, and so you get negative 3/5 because the 9 and the 3 divide out right there, and you get negative 3/5 for the slope. Now, you could also use the slope formula and think about it the same way. You get y2 minus y1 over x2 minus x1. And so now the points, you think about the coordinates of these points, that's 3, 0, and 0, 9/5. Remember, it does not matter which way you subtract when you, or the order that you subtract in when you do a problem like this. So if you have y2 minus y1, you have 9/5 minus 0, and then 0 minus 3. And so you get 9/5 over negative 3. So 9/5 divided by negative 3 is 9/5 times negative 1/3, and you get the same answer. At the end, you get negative 3/5. Those are equivalent ways of thinking about the slope. Remember that the slope of the line, is, if it's negative, it means the line's a falling line. And you can see this line's obviously a falling line. So it makes sense that we would get a negative slope. All right, so let's go ahead and put a box around this information in the middle here. That's important. It's important that you know that the slope is the rise over the run. It's also important that you know the formula for the slope of the line, that it's y2 minus y1 over x2 minus x1. You're going to need both of those things in order to be able to deal with slope. All right. So now let's look at graphing a line with the slope. We did this a little bit at the end of class. So let's use what we know about slope to graph a line. Let's say that we have a line that's passing through. We have a line passing through -2, -3, let's say, and has a slope of 5/3. Graph the line. Okay, so in a case like this, the first thing you do, definitely a kind of problem I would ask you to do on a test, to be able to work through a problem like this and sketch a graph like this. So identify the point that you are given, and you know the line goes through this point. So you know the line goes through -2, -3. So there's -2, -3 there. And then simply use the fact that the slope means rise over run, right? And so you have the slope is 5/3, and that is the rise over the run. And so this means from our point, -2, -3, we would rise 5. So 1, 2, 3, 4, 5. You literally count, and you go up 5. And then the run is 3, so you literally go to the right 3 units. Again, you're just counting there. And there's 3 right there, and that gives you a second point on the line. And that gives you enough information to graph the line right there. All right, so there's our line. So you ought to be able to do that. You ought to be able to use the slope to graph a line. That's, I think, is important to be able to do. Because I want you to be able to tell me that you know what the slope represents about a line. And this is a way for me to ask that. This is a way for me to figure out that you actually do know that the slope represents the rise over the run. Depends that it gives you how much the line is slanting. All right, so now let's look at horizontal and vertical lines and slopes. So slopes of horizontal and vertical lines. All right, so let's think about horizontal lines for a minute. Remember, we talked last time in class or in lecture that horizontal lines always have equations in the form y equals a constant. If you have a horizontal line, its equation always can be written as y equals a constant. In other words, the x is missing. Okay, so let's look at an equation like that. Let's say we have y equals 3. That's our horizontal line. So what we want to do is look at the slope of that line. All right, well, first, excuse me, first of all, let's graph the line. So when I graph the line, this line is a horizontal line that passes through the point 0, 3 right there. And really all you need is one more point on this line, and then we could use the slope formula to graph the line. So let's say I use this point right here, which is the point 2, 3. All right, so let's use our y2 minus y1 over x2 minus x1 formula to go ahead and graph this line. So the slope would be y2 minus y1, 3 minus 3, over x2 minus x1, 2 minus 0. And so that would give you 0 over 2, or 0. So the slope of this line is 0. And that is actually true for any horizontal line. All horizontal lines, this is going to happen, that the slope is going to be 0. Right? So horizontal lines, two things you always need to know about horizontal lines. Their equations are always in the form y equals a constant, and the slopes of a horizontal line always 0. Always, always, always 0. All right, so let's go to vertical lines next. So a vertical line, don't forget that vertical lines are always in the form x equals a constant. We talked about that last time. Anytime you have an equation where the y is missing, there is no y term in the equation, where it's x equals a constant, where you can write it as x equals a constant, the graph is going to be a vertical line. So let's talk about the vertical line x equals -4. All right, and let's look at the slope of this line. So x equals -4. And I'm going to give you equations like this on your next exam and say, graph this. I want you to know when you see x equals -4 that you know, hey, that's a vertical line right away. Okay, so this is a vertical line that goes through -4, 0. And let's say we pick another point, we'll use -4, 3. Right, since it's vertical, it's got to go through those 2 points. The x value's got to always be -4. So those are my 2 points on this vertical line, -4, 3 and -4, 0. So if I use the slope formula here, you get y2 minus y1, so that would be 3 minus 0 over x2 minus x1, so this is -4 minus -4. So in the numerator you get 3, but the denominator is -4 plus 4, and so the denominator is 0. So you get 3 divided by 0 here. Or if you had subtracted in the other direction, you would have gotten -3 divided by 0. Now please, please, please don't tell me that 3 divided by 0 is 0. This is not equal to 0. Right? 3 divided by 0 is an undefined expression. It has no meaning whatsoever. It's a meaningless expression. And so what happens here is that the slope for this vertical line is, it doesn't have a slope, right? And so you can either say that it's undefined slope if you want to, sometimes you'll see in a textbook that it'll write undefined slope. Sometimes you'll see that the textbook will say no slope. I am comfortable with either way, and so that will be fine either way. You write it. So all vertical lines, this is true, that the slope is undefined. So you have an undefined slope, or you could write no slope. right? That is different than a horizontal line. Horizontal lines do have a slope. It's just that the slope is 0. Vertical lines do not have a number that describe their slope. And so we say it's either an undefined slope or no slope at all. You've got to keep those straight, right? That horizontal line, so if you see the equation y equals -6, what do you think? Right away, this is horizontal because of the way the equation's written, and the slope is 0. You see the equation x equals 10, because of the way the equation's written, you know this is a vertical line, and you know that there's no slope. Right? I definitely want you to be able to distinguish between horizontal and vertical lines and their slopes. If you get confused between which one has no slope and which one has 0 slope, you can always use the slope formula to try to keep it straight, or you could use this little device here. You could literally spell the word 0, and you could spell the word no. Right? Because one has 0 slope, one has no slope. And look at the kinds of lines you use to make the letter Z and the letter N. Notice that the letter Z uses horizontal lines. And the letter N uses vertical lines. Right? So that would be a way of distinguishing the two, right? 0 slope, horizontal lines, no slope, vertical lines. I think that's a pretty nice, easy way to remember which one is which if you get confused. So think about it that way if you want to. That's awesome. However you do that, I don't care, definitely. I just want to make sure that you can distinguish between which one has 0 slope and which one has no slope. All right, so a little bit more about horizontal and vertical lines then. Next problem, this is a different kind of problem. And I will definitely ask you to be able to work this kind of problem on the next exam. Write the equation of the line that passes through -2, 6 and is parallel to the line with equation x equals 4. All right, so different kind of problem, and notice what we're being asked to do. We're being asked to write an equation here, okay? So that's what our end result's going to be here, is an equation. And we want to write the equation line, and we know this line goes through -2, 6. We also know that the line is parallel to the line with equation x equals 4. Now I want you to think about x equals 4. Now you could always draw out a problem like this. Now I don't think you need to always do that, but you could certainly draw this out to help make sense of it. So what about x equals 4? What kind of a line is x equals 4?
Vertical.
Yep, that's right. That's right, it's vertical line. That's right, thank you. And so x equals 4 looks like this. 1, 2, 3, 4 is this line right here. And now what do we have? We have a line that passes through -2, 6. Oh, -2, 6. I'm going to cheat here. I'm going to change the problem. You are not allowed to do this. You can't change a problem, but I can always change a problem just because I want to be able to get this on my picture here. So let's say it goes through -2, 3 instead of -2, 6. That way it's a little bit easier to see it. All right, so -2, 3 is this point right here. There's -2, 3. And what do we have? We have a line that goes through that point, but that line is also parallel to our line x equals 4. All right, here's x equals 4 right here. So what kind of a line goes through -2, 3, but is parallel to x equals 4? What would it have to look like? Anybody who's listening live right now, what would that line have to look like? What kind of a line would it be?
Vertical.
That's right. I got two answers there. Sandra went ahead and texted me the answer. Taylor, you answered it verbally. Perfect. Both of you are perfect. It's got to be vertical. And so, whoops. So this line has got to also be a vertical line. So what do I know? I know that the line I'm looking for is got to be vertical. So sometimes I'll refer to this as the unknown line because it's the line I'm trying to write the equation for. And the unknown line I know has to be vertical. How do I know it has to be vertical? Because it's parallel to another vertical line. So that it has to be vertical, right? It also. So that means its equation has to be x equals a constant. Because all vertical lines have equations x equals a constant. And what do I know? I know that it goes through the point negative 2, 3. And so that tells me what the equation's got to be, because the x-coordinate of that point's negative 2. The equation of this line has to be x equals negative 2. And that is my equation, right? That's the line right there, x equals negative 2. It's got to be the case. Right? And that's my answer. All right, so a different kind of problem. Not a lot of calculation to do here. It's just more of a reasoning problem where you're kind of walking through what the unknown line has got to look like. All right, so let's look at another problem like this. So again, write the equation. And in this case, the line passes through 1, negative 4, and is perpendicular. Okay, so it's perpendicular to y equals, let's say, negative 1. All right, so now perpendicular, remember, when you see that word, that means you're talking about right angles. That they've got to be at 90-degree angles, or they have to meet at a 90-degree angle. Okay, so our known line in this problem is the line y equals negative 4. So here's my coordinate system right here. I'm sorry, y equals negative 1. I don't know what I just said, but y equals negative 1 is our known line. And so our known line has got to be a horizontal line, right? Y equals negative 1 has got to be horizontal. And so here's y equals negative 1 is this line right here. And then I have a line that passes through the point 1, negative 4. So here's 1, negative 4. So I know I have a line that goes through that point, but is perpendicular to y equals negative 1. So what kind of a line would I have to have here that would be perpendicular to y equals negative 1 and passes through 1, negative 4?
Vertical.
That's right. Yep. Both of you, once again, that's right. Both of you, Sandra and Taylor, both answered perfectly. So this line has to be vertical. Notice horizontal and vertical lines are perpendicular to each other. So what do we have here? We have that the unknown line, if we reason through this problem, because the unknown line is perpendicular to a horizontal line, so it's perpendicular. That little symbol I just wrote right there, by the way, it means perpendicular. So perpendicular to a horizontal line means that the unknown line has to be vertical. And then we just use the same reasoning we just did in the last problem. That means it's got to be x equals a constant. It means it has to be, and in this case it goes through the point 1, negative 4. So it would have to be the equation x equals 1. Right? And that's the equation of my unknown line, x equals 1. All right, so I'm definitely going to be asking you to be able to do this kind of thing on the next exam. Now, we're going to look at this same kind of problem again on Thursday this week, but we're going to look at slant lines and do the same kinds of problems where we're looking at slant lines. That's a more complicated situation than these horizontal and vertical lines. So on Thursday, we'll look at slant lines and writing equations for those also. All right, let's look at one more problem. So let's say we have a line passes through -5, -2, and is perpendicular to x equals 1. All right, so let's see if we can just kind of walk ourselves through this. Instead of drawing this out, we could walk ourselves through it. So our known line in this case, the equation that or the line that we do know the equation for is x equals 1. That's our known line. And what do I know about the known line? I know that that line must be vertical, because all equations in the form x equals a constant have graphs that are vertical lines. So it's got to be a vertical line. And so then the unknown line is perpendicular to that, and so the unknown line has to be horizontal. Horizontal and vertical lines are perpendicular to each other. And so the unknown line has to have an equation in the form y equals a constant. It's got to be y equals a constant because it's a horizontal line. And then finally, I know that this line passes through 5, -2, and it's y equals a constant. So all you're doing is using the y value of that point. So this is y equals -2, and there's our equation. Right? Not, if you get used to this, not a hard process to walk yourself through. But what students will frequently do is treat these problems like the slant line problems that we're going to look at on Thursday, and then they mess themselves up because you have to do those kinds of problems differently. Slant line problems, you have more to worry about than the problem. All right, so be prepared for this kind of problem, definitely. And so this type of problem absolutely will be on exam 3. No question about that. All right. All right. So the next thing I want to talk about, let's continue. We're going to continue talking about the slope of a line. So we're going to start off with a line here. And let's say that this line is now a slant line. So we're going to get away from horizontal and vertical lines here. So let's say we have this slant line like this. And let's pretend that I know the y-intercept for this line. Let's pretend that this y-intercept is at the point 0b. Whatever b happens to be, it's 0b. All right, then what I can do is I can represent any other point on the line. I just put a point somewhere in the line, and I use variables x and y to describe the second point, because that point represents all the other points on the line. Then what do I know about this line? I know its slope, right? I've got the slope formula here. And I know that the slope is y2 minus y1 over x2 minus x1. So this would be, and just literally take those 2 points and use that formula, right? So this is y2 minus y1 over x2 minus x1. I'll call this point, using that formula, I'll call this point x2, y2, and this point over here x1, y1. So our formula would give us y2 minus y1, y minus b over x minus 0. Now, x minus 0 is just x, so that's good. So you have y minus b over x. And then I multiply both sides by x to clear the fraction out. So you have mx equals y minus b. And then finally you add b to both sides and you get mx plus b is equal to y. And now it's written backwards from the way it usually is, but what we've just done is we've just derived from a picture what we usually call the slope-intercept form of a line. The slope-intercept form is y equals mx plus b. Very important. Probably one of the single most important things you need to know about lines is the slope-intercept form. Y equals mx plus b. Right? And so what this form is actually saying is that if you have an equation of a line that's written in that form, y equals mx plus b, that the coefficient of the x is the slope, and then the constant term is the y-intercept. And see, the nice thing about this is that as soon as you write down an equation that's in slope-intercept form, boom, you've got the slope and you've got the y-intercept immediately. All right, so y equals 2x plus 3, that is in slope-intercept form. So immediately you know that this graph is a line. You know immediately that the slope is 2. Now remember, the slope is rise over run, so you could think of that as 2 over 1. Right, that would be rise over run. And that the y-intercept is at 3, is the point 0.03. You don't need to do any calculations. Because of the form, you can identify that information immediately. It's a really good form because it allows you to identify some things about the line very quickly. So notice you could actually make a sketch using that pretty efficiently here. You know that the y-intercept's at 0.3, and you know that the slope is 2, so that's rise over run. So this is simply saying that every time you go up by 2, that you're going to go over by 1, up by 2, over by 1. And if you do that forever, right, you continually fall on the line, right? These points that we're getting are all on this line. And there's the line that has a slope of 2 that goes through that y-intercept, right? And you've got a pretty quick way of sketching the line also. So it gives you good information about the line, and it also gives you a quick way of drawing the graph of the line. All right, y equals, let's say we have a negative 3x plus 1. Y equals negative 3x plus 1. So this line is in slope-intercept form. And so what do I know? That the slope here is negative 3, which we could write as negative 3 over 1. And the y-intercept is at the point 0, 1, because the b value is 1. So really fast, nice, quick way of getting some information about the line. And then it also gives you an opportunity here to make a sketch of the line pretty efficiently. So, is there a question at all? Is everybody okay? All right, so you've got the point 0, 1, and so let me put that in red. Let me be kind of consistent with the last problem. So there's 0, 1 right there. And then the slope is negative 3. So the slope means rise is negative 3. You go down 3. 1, 2, 3. And then you go over 1. And then you can continue to do that down 3, over 1. Right? And you continue to get points on this line. Right? This is a falling line because the slope is negative. And there's the graph of the line right there. Right, you're going down 3 over 1, down 3 over 1 forever. All right, so I think hopefully that's okay. I still have more to do with the slope-intercept form. We want to have a good, solid understanding of that form before we move on. So next problem, let's say we have y equals negative 3 halves x minus 2. Negative 3 halves x minus 2. So the slope of this line, equations in slope-intercept form, negative 3 halves. Now remember, if the slope is negative, do not think of that negative sign as being on both the numerator and the denominator. Because if you thought about it that way, then you're saying that both the numerator and the denominator are negative, which means you really have a positive. That's not what you're talking about. You have a negative answer, a negative number here. So either the numerator is negative and the denominator is positive, or the numerator is positive and the denominator is negative. Either way you think of it is fine, but you've got to think about it one of those two ways if you're going to use this to graph. So the slope of this line is negative 3 halves, and then the y-intercept is at negative 2. So 0, negative 2 is our point. All right, so let's have a look at this graph. So 0, negative 2 is this point right here. There's our y-intercept. And so let's see, the slope is negative 3 over 2. So if you think of it as negative 3 over 2, then our rise would be negative 3 and our run would be 2. So that means I would go down 3 units and I'd go to the right 2 units. But you could also think of this slope as 3 over negative 2. And so now my rise is positive 3 and my run is negative 2. So positive 3 means I go up 3 and I go back to the left 2. That's my run being negative. And that gives me 2 additional points on the graph, depending on how you think about the slope there. Notice you get the same line either way. Right, and so there's my line, like that. Okay, so I think hopefully no questions. So hopefully we're doing okay here. So let's see. Let's look at this next problem. Find the slope and the y-intercept. But now notice this equation of 5x minus 3y equals 8 is not in slope-intercept form. And so because it's not in slope-intercept form, I need to first do that. First write in slope-intercept form. And so to put it in slope-intercept form, right, you have to have it as y equals. Because remember, the slope-intercept form is y equals mx plus b. So in other words, when you, to write the equation in slope-intercept form, when you see those words there, what you're really doing is you're saying solve for y. Solve for y. Get y by itself. So that's really what we're trying to do here. So you have 5x minus 3y equals 8. You get the y by itself by subtracting 5x from both sides. And notice I want to put the x first because of the slope-intercept form. Now that equation is not in slope-intercept form. The next thing you have to do is divide everything by negative 3. And when I say everything, the way to look at this is you divide every term by negative 3. That's the way to think about the calculations here. So that gives you y equals, and then on the x, you have a negative 5 divided by a negative 3, so that's positive 5/3 x. And then you have a positive 8 divided by a negative 3, so this is minus 8/3. So there's the equation in slope-intercept form. All right, so then what's the slope from that equation? Right now it's in slope-intercept form. The slope is 5/3. And the y-intercept, I don't want you to just write -8/3. I want you to write the y-intercept as a point. So write it as 0, -8/3, like that. Right, and that gives you the information that you were looking for that line, slope and the y-intercept. All right, let's see. So the next problem I want to look at, a problem where we're writing the equation. So write the equation of a line passing through -6. No, I'm sorry. Passing through, and let me erase that. Write the equation of a line with, this is better, y-intercept at 0, 6, and with slope of -2/7. Right, so that's pretty easy to deal with here, because what do I have? I have the y-intercept and I have the slope. Because I have the y-intercept and the slope, I can just use y equals mx plus b to write this equation. So this would be y equals -2/7 x plus 6, right? Because the y-intercept's at 6. And that would be the equation right there. That's an equation of a line that has a slope of -2/7 and a y-intercept at 6. All right. Next problem. So let's see. Let's say we have a line. This is the graph of the line here. So that's my line right there. And the instructions here are, write the equation of this line. All right, so to write the equation of this line, first of all, we identify that the y-intercept of this line, we can read it off of the graph that the y-intercept is at the point 0, -1. And I also want you to notice that you can actually read the slope of this line as well, because notice that, pick a point on the line that you can clearly see that the line goes through. And let me do something different. Let me use this point way down here. I can see that the line goes through that point down there. And so notice I could read off the rise and the run between these 2 points. Right, the rise would be down 1, 2, 3, 4, so down 4, and the run would be to the right 2. And so the slope of this line from that picture, and I could have picked, by the way, any point that I could identify the line is passing through would work here. This is never a problem, no matter what the point is. So this is rise over run, and you get -2 as the slope. Now let's say I didn't pick that point. Let me show you here. Let's say I picked this point way the heck up here. And I know the point 0, -1. I was told that the line goes through that point. But look at that second point there. The rise is 1, 2, 3, 4, 5, 6. The rise is 6 to that point. And the run is back to the left 3. So the run is -3. And so notice there, the rise over the run would be 6 over -3. And notice you still get -2. It does not matter what points you pick. You're always, always, always going to get the same slope no matter what. All right, so what do I have here? I have the y-intercept for this line is at 0, -1, and the slope is -2. So those two pieces of information I can put together and write out the slope-intercept form of the line, that this is y equals negative 2x minus 1. Right? It's y equals mx plus b. So m is negative 2, and b would be equal to negative 1. All right, so hopefully we're okay here. Nobody has a question about this. So I'm not hearing any problems so far, so that's good. So let's see. Let's finish this discussion here a little bit with parallel and perpendicular lines. If you have slant lines, so I'm talking about slant lines now, not horizontal. When I say slant lines, I'm talking about lines that are not horizontal or vertical. So not horizontal, not vertical. So if you're talking about slant lines, parallel lines, lines that do not intersect, always have equal slopes. And perpendicular lines, lines that meet at right angles, remember, but remember, not horizontal or vertical. Perpendicular lines always have slopes that are opposite reciprocals. Okay, that's different. So opposite reciprocals would go like this, that if you have the slope of line 1 to be 3/5, then the slope of line 2, if line 1 and line 2 are perpendicular, that's what this symbol means right here, that they're perpendicular. So if line 1, and I shouldn't use M there, let me erase that. So let's say line 1, so L1 and L2 are perpendicular. Then the slopes are, which would be M1 and M2, are opposite reciprocals. What that means is you take the slope of the first line and you flip it and change its sign. So when you're talking about opposite reciprocal for 3/5, it would be negative 5/3. Okay, so we finished the day today by looking at a couple of pairs of lines, and this is the question. Are these lines parallel, perpendicular, or neither perpendicular or parallel? Right, so that's our question here. So we'll start off with some easy ones. So if you have y equals 5x minus 3 and y equals 5x plus 8. Right, we have two lines there. Both are in slope-intercept form. The slope of the first line is 5. The slope of the second line is 5. So what do we see here? That the lines have the same slope. These have to be parallel lines. Right, if I was to graph these two lines, I'd get that they're parallel. Y equals 3/4 x minus 6, and y equals negative 4/3 x plus 1. Right, both of those equations are in slope-intercept form. The slope of the first line would be 3/4. And the slope of the second line would be negative 4/3. And what do we see about those slopes? That they are opposite reciprocals, right? You could flip one and change its sign and you get the other one. And so that means if I graphed these two lines, I would find that they meet at right angles, that these are perpendicular lines. All right, the next group of problems, let's say I have, or a group of lines, let's say I have y equals 2x minus 3 and y equals negative 2x plus 1. All right, so the slope of the first line is 2. The slope of the second line is -2. So 2 and -2 are not equal to each other, so the slopes don't equal. They're not parallel. The slopes are also not opposite reciprocals. You don't flip one to get the other one. Remember, you have to flip it when you're talking about perpendicular lines. So these are not perpendicular either. So this is neither in this case. These lines intersect, but they're neither parallel nor perpendicular. Right? They're definitely not. They definitely intersect, but they're not. They don't meet at right angles. Certainly not parallel. All right, 2x plus y equals 6, and x minus 2y equals 8. All right, so those lines are not in slope-intercept form. And so the first thing you would do is put both of those in slope-intercept form before you answer the question. So in other words, you solve both of them for y. So in that first equation, I get y equals -2x plus 6, and I'm done, right? That line's in slope-intercept form. All I did is subtract 2x from both sides. And so the slope of that line's -2. The second line, a little bit more work to do. I subtract x. So you have -2y equals -x plus 8. And then you divide by -2. And you have y. Now be careful, you're dividing by -2. So the signs change on both of these terms. And so you have y equals +1/2 x minus 4. And so the slope of this line is +1/2. And so notice that these slopes are opposite reciprocals of each other, and so these are perpendicular lines. These are perpendicular. All right, so I would definitely, this is a kind of problem I definitely ask on an exam on slopes, and so I give you a pair of lines and ask you to tell me whether they're parallel, perpendicular, or neither parallel or perpendicular. It should not be a hard problem to be able to answer. So, all right, so let's see. You've got web assigned homework that's due this afternoon. All of chapter 9, or I'm sorry, all of chapter 10. And I did want to find one other piece of information here for you, just to make sure that you're aware of. So the rest of your web assigned homework, I was looking it up here on my computer real quick, or the next web assigned homework after today is due on the 8th of April, and so that's 4.1, 4.2, and 4.3. So that should be pretty easy. That's one assignment. 4.1, 4.2, and 4.3 is due April the 8th, and I'm not going to extend that date. Right? That should be that's one assignment that covers those 3 sections. It's just on graphing lines, and you should be okay with that, and should be able to get that finished by the 8th. And then the next homework after that's due on the 15th, with more stuff on lines. So, all right, don't forget that exam 2. You can get a graded copy of that back by emailing me, so that's okay to do. If you have any questions about something, please don't hesitate to ask me. Send me a remind message, send me a web-assigned message, email me. You have all those different ways to get in touch with me. I'll be happy to try to help you out. Anybody have any questions? Those of you who are left